Okay, horizontal asymptotes, these can be crossed. So a horizontal asymptote can be crossed, and we'll see some graphs where we'll see that. So rational functions have at most one horizontal asymptote. To find it, you are comparing the degrees of the numerator and the denominator. So you're looking for the term with the highest exponent in the numerator and the denominator. So if the degree of the numerator is larger, so if it's bigger on the top, there is no horizontal asymptote. If that numerator is bigger by 1, so for example, x to the 4th over x to the 3rd, then that means you're going to have a slant asymptote, and we'll talk about what that is next. If the degree is bigger in the denominator, so bigger on the bottom, so think Bob, you can write Bob, then your horizontal asymptote is y equals 0. So if it's bigger on the bottom, it's y equals 0. That's the equation of your x-axis. The last case is if the degrees are the same, then your horizontal asymptote is going to be the ratio of those leading coefficients. So let's take a look at those three cases down below. The first thing that I do is I circle or highlight the term that has that highest exponent in the numerator and the denominator. So here I have x to the 4th in the numerator and x to the 3rd power in the denominator. So are they the same degrees? Is it bigger on the top or bigger on the bottom? So it's bigger on the top. So if it's bigger on the top, there's no horizontal asymptote. This one is actually one of those special cases where it would have a slant asymptote. The next one, part B, again, look at the term with the highest exponent and then compare the numerator and the denominator. Are they the same degrees? Is it bigger on the top or bigger on the bottom? If it's bigger on the bottom, then there is a horizontal asymptote, and it's always just simply the equation y equals 0. So you can see this one right here. There's your horizontal asymptote right there at y equals 0. The last case, I look for the terms with the highest degree. Are they the same? Is it bigger on the top? Is it bigger on the bottom? Now, these have the same degree on the top and the bottom. So that's this third case. And your horizontal asymptote is the ratio of those leading coefficients. So 5 over 1, it's going to be that equation 5 equals 1. And so here's an example. Here's the equation 5 equals 1. You can see that horizontal asymptotes can be crossed. So only parts of the graph are going to use that asymptote to approach, while other parts might cross it.